Welcome to this video lecture on calculated measures, hierarchies and key performance indicators within the Microsoft SQL Service Analysis Services tools. Throughout the lecture series we've been talking about the process of data warehousing and how multiple sources such as databases, occasional reports and web sources can be extracted, integrated and then loaded into data structures such as stars and cubes and then fed on to the end user. Those end users may well be writing routine printed reports or doing some sort of dashboard displays or using Excel or other tools to be able to self-service explore the tools or finally pass on to data mining. In this class we look at how calculated measures and key performance indicators can be added at the stars or particularly the cubes level to be able to provide the business analyst with pre-made standard measures that help them display and interpret the data. So most of this video class will be a practical demonstration, firstly of how to view the calculated measures and the key performance indicators once they've already been set up, but then we'll backtrack and see how these were designed into the data cubes themselves. In this example we've got the AdventureWorks data set with facts from our internet sales and from our reseller or shop sales and various dimensions such as currency, customer, dates, the number of products, promotions and so on. And within the facts we've restricted this to just a small number of measures. So we've got the order quantity, the amount we sold, account and the total cost of producing these. So we could, for example, look at the number, the volume of internet sales account and the volume of shop sales accounts. That would give us the total ever from our different channels, and we could drill into that based on dates. So we could split each of those figures into its different year contributions, and indeed if we drill into any of these we could see the sales for internet and the sales for shops by months. However, a lot of the business analysts would want to know the total sales as opposed to the different channels, and they could get this by using this as a conventional spreadsheet and typing in conventional spreadsheet sort of formulas such as the B2 cell plus the C2 cell, and that would give the total of these two added together, and then we could copy and paste that formula to get the totals for these other rows. Now that does give us the total for each year's sales, but as we drill into the data, the formula now on the fourth line relates to the January from the 2006, and we would have the inconvenience of having to copy this formula around to be able to see all the data. And as we drill out again, you can see really this is a rather inelegant solution. So instead what we can do is delete all of these, and then when we built the cube, as well as having the facts for the internet sales and the reseller sales, we could create some calculated measures which are going to help us work out various business related things. So let's have a look, for example, at the total. We have the total sales. Now let's have a look at the total costs. So this is the, in fact I'd like to try this again. I'm going to put the total sales in and then the total costs. Let me get that the right way around. There. So instead of just seeing the internet sales and the reseller sales, we've now pre-added those together. Let's take those away. And this is our overview. Total sales and total costs. Many business people would like to know the profit from each of these years, and they would get that by subtracting the cost from the sales. And again, we could type in formulas here, but instead we could use a calculated measure and pre-design it into the cube. So let's bring in the total profit. And can you see it's going to be the sales minus the costs give the profit. And the big advantage of this is, as we drill in, we will be able to get this formula replicated right down to the individual detail. Drill back out again. It's not just the total profit that's useful. Many business analysts would like to know whether the profit's going up or down over the while. So this is the total profit, but if we divided the sales by the costs, we would get a ratio of how much profit were we making out of the cost. For example, if the sales and the costs were equal, then we're breaking even. We get a ratio of 1. If we were selling twice as much as it was costing us, we would get 2 as a ratio. And if it was costing us twice as much to deliver as it was to as we got for income, we'd only be getting a ratio of half. We'd be making quite a serious loss. So you can imagine why a lot of business analysts are interested in looking at that level of detail. And here we have a calculated measure that we can bring in, which looks at the difference, the ratio between this and this. In this particular one, I'm going to reset this as a number, just so we can see it slightly more clearly. There we are. So we're making a 10% profit in that year, and as we drill in, we can see the profit actually varies. Sometimes it's 15%, sometimes it's 11%, sometimes we're down as low as 2%. Let's analyse why that might be. And indeed, we might go even further than this. This is the profit rate, but are the profits going up or down overall? And to do that, business people very often want to compare this year against last year, for example. So here's a further calculated measure, and we could look at the previous year's, the previous profit. I'll explain why I hesitated there. Now, can you see here that in 2005 our profit was 17%, and there wasn't a previous profit the previous year. Then we had 11%, which is, sorry for the hesitation. I'm going to also make this one 2 digits to make it easier to see. So let's format the cells to 2 places. There we go. So we had 17% in that year, 11% in 2006, and the previous profit was, of course, that figure, 1.7. In 2007, the profit was 10%. In the previous year, it was the 11. And now, can you see, we're going to be able to look at the trend here. We've gone down in profit from 17 to 11. We've gone down in profit, and then we've gone up. So, final calculated measure is the change. And bring that in. And this is now the difference between that figure and that. Again, just for convenience, I'm going to format the cell so that you can see it nice and clearly. There we are. In fact, if I format it to enough digits, you can see we've gone down in profit, and that year we went up. This clearly is a very helpful figure for the analyst, but in fact we can go further than that. Just to create some space, I'm going to take away the different costs. So now we've got the total profit, the percentage, what the previous percentage was, and the ratio of change. I could take away that, so that's giving us a summary. And then have a look at the key performance indicators. And we could look at the status of this figure. Is this figure good, medium, or bad? Let me move that up 1 column so we can see there. And in our business, we're defining anything that's 15% profit or greater is good. anything that's between 15% and I believe it's 5%, we'll have a look at that later, is okay, and anything less than 5% is a serious warning. As we drill into the data, we can see that month by month, some months we do very well, many months we do okay. This particular month we actually managed to make a loss. Can you see how having these traffic lights is going to help the analyst very quickly home in on the problem months? Look, here are two when we only just break even. I'm just wondering, when I look at this visual trend, to see that during the winter months we do okay, the summer months we're rather struggling during that time. So my point is here, these visual traffic lights are going to help the analyst zoom into the problematic areas much more quickly than just having a blank row of numbers like this. And then we've got the trend here, and we can look at that in more detail by bringing in arrows. And here we can see that we've got a downwards trend, we've got a further downwards trend, we go up, and then because we make no sales in those years, we drop down. And again, drilling into those, we can see the way that our data is travelling, the direction our data is travelling. So these calculated measures allowed us to add some business intelligence to the raw data, and then we added key performance indicators to help us visualise the overall levels of data and whether they were achieving our targets and whether the trends were in the right direction. So we've explained the use of calculated measures and the use of key performance indicators. Let's now have a look at how these were implemented. So I'm now going to show you an analysis services project. In the same way as you've done previously, we've connected to the AdventureWorks dataset and then created a data source view of this. It's a moderately complicated view, but you can see here we've got the facts for the resellers, we've got the facts for the internet sales, and then we've got various dimensions around the outside, one of which is the date. At the moment we have a cube. I'm going to delete this cube and then rebuild it completely from scratch. But because I've previously built the cubes, I won't have to rebuild the dimensions. They'll stay as they were from the previous build. So I'm going to start a so-called brand new cube, taking from these existing tables and then finding out where might the facts be. And they're in the facts internet sales and the reseller sales, but not the resellers themselves. Next, we're going to choose which of the measures that we want, and for this particular example I'm going to restrict it down to the number that we buy, the amount of cash that we earn, the total product cost, and a count. And then similarly we're going to go for the number ordered, the amount of cash earned, the total cost of manufacturing these things, and the count. We're going to reuse all the existing dimensions. I'll explain one or two of those in a moment, particularly the hierarchies. And we don't want either of the facts tables to become dimensions themselves, because these contain numerics only. They contain no descriptions that are useful to us. There's no way we're going to drill into these as dimensions. They just contain the measures. And we should be ready to build the cube. So I'll set the cube building, and off it goes and deploys, and that was quick. And we've now got the cube, which I could go and browse and bring back the Excel just as we had it previously. So that's exactly the situation we had in the previous demonstration. Close that. And then I just want, oops, I thought I closed that. And then I just want to explain some things about the hierarchies, particularly the dates. These are all the possible attributes within the dimension, of which I've selected some by dragging them. Let's not do that one, let's do the fiscal quarter. We could drag it across and that would now appear in the drop down menus of the Excel sheet. And then I've taken some of these and put them into a hierarchy. So when we drill in from these, we will be able to drill starting with all dates, then seeing by year, then we could drill into the month, and then we could drill to the specific day. Let me delete that again because I didn't want that as part of my demonstration. Likewise, for example, we have various attributes to do with products, and we've selected just some of these from our data set to put into the menus for Excel, and then we've dragged some of these across to make a hierarchy for all products, and that will start with a category, we drill into the subcategory, and then into the product itself. For the customer, these are the different things that are available from the data set, and we've selected just some of these. Notice here that although we have made a hierarchy for the locations of which country or which region they live in, which state or province and which city they live in the hierarchy, there are some things that don't fit into the hierarchy. For example, gender is unrelated as to where they live, or the marital status is unrelated. So these are all the things that are available in the menu, some of which have been put into a hierarchy. The notion of these hierarchies, and particularly to do with dates, is going to become very important as we progress through this class. Now let's have a look at the structure of the cube. So I'm going to select the cube and then go and find, I'll close down some of these first. Oops, let me just sort this out. Oh yes, of course, we've made the change, haven't we? So we need to save that. Good. Right. So we're now looking at the cube and the cube structure. And you can see here we have the list of dimensions in our cube and the list of measures. And the measures include the things that we selected earlier, the orders, the quantity, the total cost, the total sales amount, and the count. And likewise, the same four things for the resellers. But what we don't have is any way of joining those together via the, to make it easy for the analyst. So what we'd like to do is add some more calculated measures, which typically are going to add together the product costs and the order quantities, the sales amounts, and then we'll be able to have further calculated measures that work out the ratios and the rates for doing these. So let's set up a new calculated measure, and to do that we visit the cube and then select the calculated measures area and click on the wizard for a new calculated member. In our case, our first calculated measure is going to be the total sales. So we will put in its name first, which is square brackets dollar total sales. The square brackets just indicate that there could be a space in the name, and the dollar is not significant. It helps remind us that this is going to be a monetary value. And the total sales is going to be made out of taking the measures, let me just move that up a little bit, finding the existing measures and adding together the internet sales amount plus the resellers sales amount. And we can set the type of this to be currency. So we've now got a new calculated measure. It's the total sales from both our sources. Let's also set up, as well as total sales, a totals costs. So we're going to do a new calculated measure this one is going to be the amount of money of the total costs, and likewise it's going to be the internet sales total costs plus the reseller total costs, which is again a currency value. And now we've got those two, we could work out the difference between them, which would be the profit. So again, a new calculated member, and let's call that the amount of profit, and the formula for this is the total sales minus the total costs, and that's a currency amount. Okay, I'm just going to copy this because a fourth measure is not going to be the addition between the total profit, but it's going to be the ratio between those two. So we can set up a calculated member, and this one is going to be the ratio of profit. Again, the percent symbol is just symbolic, it's just helping us remember that. And instead of doing a subtraction, we can do the division. And as we mentioned, if the total sales is greater than the total costs, we're going to be in profit. If the total sales is less than the total cost, the figure will be less than 1, and we can set this one up as a percentage. So let's run the cube and switch to Excel, refresh the data, and we should now be able to see the total profit and the, I beg your pardon, let's do the total sales and the total costs. These two add together to be the total profit, and then we can even see the overall profit is 12% when I've reset the format. There we are, rounded to 13%. And as before, this is a major point, we can drill in on those, and without any further programming, these figures here are related to the selections there. So as we drill in, these figures relate to those selections. One of the key points about this is how context sensitive, if you like, this data is. So let's minimize that and go back to our design. And we've got these 4 measures at the moment. So now we want to go that one step further and add in the 2 extra calculated measures that are going to allow us to look up last year's profit and then compare this year's with last year's. And to speed things along a little bit, I've already entered these. So under the previous profit, here's the name for the previous profit. It is, now let me explain this first, take that away. It's going to be use the formula for the current profit, but apply it to the range of dates that are one previous to the current set of dates. If in Excel we were looking at dates 2007, then this previous member would say that we were to apply this formula to 2006. On the other hand, if we had already drilled in into, let's say, February 2007, then this formula would find the current date, February 2007, look back one, which would be January 2007, so it would apply the formula that we've set up to the previous date. And we can set this to be a percentage. And also, having got that, we could look at the rate of change. And the rate of change is going to be the current profit for whatever time selection we have, divided by the previous level of profit. So again, if we've made more money than last time, this rate will be greater than 1. If we've made less money than last time, it would be less than 1. And we can regenerate and switch, refresh all, and this time we should find those extra values in here. So we have the previous rate. Do you remember it was going to look that way? Oop, let's set that to the format to There we can see those comparisons, and we can even see the rate of change. Again, format and number, you can see those rates. Oops, last time we did this, it was more convenient to set the format to have extra digits so you can see the detail of them. So that's rebuilt the pattern that we had previously. Let's now add the visual displays to go here. So we will minimise the Excel and have a look at the key performance indicator facility instead. Key performance indicators are created by having a new KPI. In our particular case, we're going to call it performance. The value that we would like to be indicating the overall percentage profit, so we can drag in that. We would like to detect whether the profit is good, okay or bad, and the way to do that is to write a small expression which I'll paste in, and then we'll go and look at it. So this is saying when the percentage profit is 15%, then that is good. When it's between 15% and 5%, it's okay. Oops, let's go to that. Okay. Otherwise, it's bad. And Excel will display one of the different indicators to show good is 1, yellow will be okay, bad will be red. But we can also track the trend by comparing the ratio of change. And this one is when the ratio of change that we set up earlier, if we've gone 5% better than last time, then that's good. If we're worse than last time, we're saying that's bad. And if we're between 1% and 5%, then that's okay as a rate of growth. So let's again all that, or build the cube from all of that, and switch to Excel and refresh. Now I'm just going to lose the total sales and the total costs, so there's a little bit more room to be able to see this. And you can see now we've got these key performance indicators, and one of them is the status of how well our business is doing. I'd just like to move this up a little bit so we can have a bit more room to see here. And the performance, this is actually against this figure here, so I'd like to move the performance up. So this is now a commentary. 17% is great performance. 10 and 11%, that's fine. 19, okay, it's great again. Let's drill into one of the years, and we can find, whoops, we're getting some bad performance. I'm going to hide this previous profit ratio just to give a bit more space on the screen. This is the comparison against the previous year. So let's go to the KPI and whoops, and find its trend and drop the trend in. And this is now showing that the trend here, we've gone down, we've more or less held steady, and let's find a good trend that was 5% or more up there. So may we return to that statement we made at the beginning, that these status values give you a quick visual indication of which are the good years or the good months, which are the bad months, and so on, and the arrows give you a feeling for the trend. Returning to the summary of the class, we've shown you a demonstration of calculating calculated measures and the key performance indicators, well, viewing them within Excel, and then we showed how they were designed into the data cubes. In previous classes, you've used Excel to be able to draw visualizations of the aggregated data sets, but these automatically added all the time, and then you could draw graphs from those. These visualizations were great, but what you've now seen is we can go in more detail and get some indicators based on the key performances. These are very useful. A lot of businesses use dashboards, web pages or screens summarising the overall values, and you can see here the traffic light effects or the graph effects to give overall visualisations based on what's good, acceptable, bad. This particular one was done in Cognos rather than in Excel. Alternatively, we've used Excel to be able to look at self-service analytic tools where, rather than being fixed designs, the analysts themselves can explore the data, drill in, drill up, drill down, and so on. In summary then, a calculated measure. It's a formula that you put right inside the cube that calculates, each time you use it, a measure relative to the level of drilling that you've used. The big advantages of calculated measures are they significantly enhance the usability, the friendliness of the cube for the analyst. Another major advantage is that the cube itself, Excel, will automatically add columns of numbers, but calculated measures allow us to do the business maths as opposed to just additions. So for example, we've not shown it, but you could have a rolling average. You could smooth out a graph by taking the 2 months before, the current month, and the 2 months after. And then each time you click on a month, it will recalculate those particular months. Businesses often look at return on investment. If you put something in, how many years will it be before you get your money back? And we've looked at profit ratios. Many of the calculated measures use functions such as year to date or parallel period to be able to see data between different dates. But then, it is a valid question. Why not build in these calculated measures at the extract, transform and load so they don't appear to be anything different? Why not just have them as part of the measures of the different facts tables? Part of the reason is that if you build in the values right into the cube, then you do inflate the size of the cube quite considerably. If every single line in the facts table has these extra measures, then it's going to be considerably larger and therefore slower to use. But the second reason is, if we've said throughout the module, try to build cubes that are specific to the analyst's business interrogation needs, and it can be easier to build them into the cube as opposed to into the underlying data source. One of the key things we've relied upon in this particular explanation is the idea that you can have hierarchies in the data, and that helps you explore the data. So this particular hierarchy is for dates, with all dates divided into years, 2009, 10, 11, 12 and so on, and these years can be broken into quarters, quarters can be broken into months, and the months into days. And we can do such things as, if we're on a particular quarter, then if we ask for the previous member, if we're in quarter 4 of 2009, that's going to relate to quarter 3. If we were in March 2009, that would relate to February 2009. If we're on the 3rd of, it looks like January here, then the previous member is the 2nd. Or we could ask for the next member. It also makes sense to ask for the year to date. So if we are on the 5th of January, the year to date is all of these. If we're on May 2009, then the year to date is the addition of all of those. If we're on the 2nd quarter, it's those 2 quarters. Can you see how year to date works? Parallel period is, if we are in April and May 2009, then the parallel period previously is 2008, April to May. Or if we're on the 2nd, 3rd and the 4th of January, the parallel period, if we went 1 month forward, would be the 2nd, 3rd and 4th in February, for example. So the MDX, the multidimensional function, makes a great deal of use of these date-aware queries. And then the key performance indicators. They are an at-a-glance visual display that allow measures to quickly be understood by the analyst. Typically, a key performance indicator consists of a measure, and then a target that you want that measure to reach. The status is its current value. How far off the target is it? And in our case, we've used traffic lights, the red, yellow, green, to show that we've exceeded, or we're approximately at, or we're somewhere beneath the measure. And then very commonly, you want to be able to compare the value this year against the previous value, and that will lead to an arrow such as an up, level, down. And the advantage of key performance indicators are that the concept is all very widely understood in business. Many businesses use key performance indicators. The second technical advantage is if you build it into the cube rather than letting each business analyst define their own key performance indicators, then you can have a common definition right across the company, one standard definition of what the acceptable, the okay and the non-acceptable values are. And that leads to far greater consistency when different analysts are exploring similar sorts of data. So, we hope you've enjoyed this video on calculated measures, key performance indicators, and why hierarchies are so important within the MDX query language to be able to generate the right sort of data. Thank you for watching.